For all of Newton's laws, make sure you have the definition memorized. Now, I've put what I think is the best definition up there. So Newton's first law, an object will remain stationary or in constant motion unless acted on by an unbalanced force. And so that's the one I recommend to memorize. The second thing you need to be able to do is interpret it for different situations. So you'll be given a picture of something. Now, it is more professional to actually draw the diagram in there as well. And so for this one, you'll always do the size of the arrow must be the same and it must be equal and opposite. And it's always good to name the forces as well. So an important one to learn is normal force. So if something's not moving, the surface it's sitting on, that the force that is called the normal force. So it's the force that surfaces exert to prevent solid objects from passing through each other. So I've named that the normal force. In this case, it's a 1 kilogram weight. So W equals mg. We learnt that. We'll learn that actually. In Newton's second law, what the actual force is, and so that's 1 kilogram by acceleration due to gravity is g. So that's 10 newtons down. So we know the normal force up must be 10. So the size of the arrow indicates the size of the force also. So I've drawn that both in. Normal force 10 newtons up, weight 10 newtons down. It's balanced and so it's not moving. So you would say this as the weight remains stationary as the force of gravity pulling down is balanced by the normal force pushing up. That would be a great way to state Newton's first law as a particular example. Now, they demonstrate Newton's first law. They often do this like pulling the sheet out of a table trick, and all the plates and stuff stay the same. And it doesn't actually make much sense. This one makes a little bit more sense because something actually falls down. It's actually hard to interpret why is that Newton's first law, because there is the normal force still acts when you pull the sheet out. So this one here, it actually falls down. So when I remove the paper, I'm removing the normal force, so it's unbalanced. And so a good way to say this one is the screw falls down as the normal force pushing the screw up is removed, leaving an unbalanced force of gravity pulling it down. Therefore, it moves down. So that's an example of sort of Newton's first law, that an object will remain stationary in constant motion unless acted by an unbalanced force. And because it's an unbalanced force, it doesn't remain stationary anymore. Okay. Now this one here, now I'm going to the one that's actually moving. So you can see that I move it at a constant speed, and you can read that on the force meter. So I know it's 1 Newton. So therefore the friction must be 1 Newton in equal and opposite direction. So a good way to write this one is the weight moves at a constant speed as the pull of 1 Newton force is equal to the pull of friction. Now I'm going to then just increase the friction to 2 newtons. I know that because it takes 2 newtons to pull it at a constant speed. And so for the next example, you can just say if we increase the friction on the carpet, then we need to increase the force of the pull to 2 newtons to keep the forces balanced and so in constant motion. And that's because the friction's now 2 newtons.